Hey guys, welcome back to my channel. How's it going? In this video, we are going to explore combinations, a fundamental concept in combinatorics that helps us count the number of ways to select objects without the regard to order. We'll derive the formula for combinations, see how it relates to permutations, and apply it to real-world problems. So what is the combination? Unlike permutations, where order matters, a combinations focus on selecting objects without regard of order. For example, if we have three letters A, B, and C, so we have a set of A, B, and C, we need to choose the only ones without the regard of order. If we take a look at the permutations, we'll have ABC, ACB, BAC, BCA, CAB, and CBA. So that's our permutations. But if we need to select only combinations of them, we are only interested in the selection itself, not in the arrangements. So the groups A, B, C, B, A, C, and CBA are all considered the same selection. In this case, the selection of three letters from this group will be essentially one simple selection, which is ABC itself. This key difference leads us to the formula for combinations. The generalized formula for combinations will be C n taken R, which sometimes also denoted as n taken R like this, will be equal to n factorial over r factorial times n minus r factorial. This formula comes from the permutation formula, but it includes a division by r factorial, which accounts for the fact that different orders of the same selection should not be counted multiple times. If we take a look at the given examples with ABC, we can notice that each arrangement here has essentially 3 factorial of possible combinations. We'll have CBA, we'll have BAC, and so on. We have total 6 possible ways of arrangements. That's why we need to divide this by 3 factorial. If we were about to count all the combinations here, we would probably choose the following tree structure. Suppose we would like to select the arrangements of 2 letters without any regard to the order. In this case, we would select something like A, B, A, C, C, B. That will be enough. But if we needed to find the permutations P, 3 taken 2, we would compute them as 3 factorial over 3 minus 2 factorial, which equals 3 factorial over 1 factorial, which equals 6. And let's take a look at them. That will be AB, BA, BC, CB, and CA, AC. And we can now see that each has 2 possible arrangements of the same letters with regard to the order. 2 possible arrangements here, 2 possible arrangements here, and 2 possible arrangements here. If we needed to compute the total result, we would say 2 plus 2 plus 2, which is the total, which equals to 6. If we don't really need the order, we would say that selections will be equal to 6 divided by 2, which equals to 3, which actually equals to 3 factorial over 2 factorial times 3 minus 2 factorial, and satisfies our formula, and that will be equal to 3. So this is the key idea that you have to grasp when it comes to the combinations. An important property of combinations is that n taken r will be the same thing as n taken n minus r. This means that choosing r objects from n is the same as leaving out n minus r objects. For example, you can show that C3 taken 2 equals the combinations 3 taken 1, where C3 taken 2 equals 3 factorial over 2 factorial n minus 2 factorial, whereas the C3 taken 1, which will be equal 3 factorial over 1 factorial times 3 minus 1 factorial. So this is the same thing, this is 2 factorial, and this is 1 factorial. So denominator remains the same. As a result, we have 3 over 2 factorial times 1 factorial, which will be equal 3. Here it is. You can essentially see that selection of one letter from our ABC example. The selection of one letter is essentially A, B, or C. If we took 2 letters from here, it would be AB, BC, or CA. Now let's take a look at more concrete example. Suppose we have 9 players in a basketball game, and we need to select a starting lineup of 5 players. The order n in which we pick them does not matter, only the selection does. So the using formula C9 taken 5, we have, or another notation like 9 taken 5 equals to 9 factorial over 5 factorial times 4 factorial, which will be equal to 6, 7, 8, and 9 over 4 factorial, which will be equal to 126. So there are 126 different ways to select the starting lineup. The key takeaways from this video is that a combination is a selection of objects where order does not matter. Cn taken r equals to n factorial over r factorial times n minus r factorial. The property of symmetry always holds. That said, our n taken r will always be equal n taken n minus r. and it allows us to simplify the calculations in some cases. The combinations are widely used in real-world problems like team selection, lottery probabilities, and committee formation. Combinations are a powerful tool in probability and combinatorics, allowing us to count selections efficiently. In our next video, we'll make use of these combinations in the binomial expansion formula. Thank you for watching this video. As always, hope you found this video helpful. If you have any suggestions or any improvements for this video format, or you have any questions left, please feel free to leave them in the comment section below. I really appreciate your feedback. For more technical discussions, you can reach out to me via Discord or LinkedIn, or you can join our Discord community. You will find the link in the description section below. And as always, see you in the next episode. I wish you all the best in your learning journey. Take care.